Okay, so as we get ready to get back into our notes, we were working on double angle and half angle identities, but we had just barely started that last time. My goal was to get you guys through the notes, and then I'm going to give you sort of a heads up of which problems to focus on before you do that test that's over 7.1 through 7.4. Okay, so these were our double angle identities. And if you remember, cosine is the one that we had multiple options on how we could plug in. And so we did a couple of examples here where we chose, based on the information we had, what we thought might be the best replacement on cosine. If it was sine of 2 times theta, or tangent of 2 times theta, we didn't have an option. We had to use the one formula that exists for that. And then we worked on this where we figured out which quadrant our angle was in for angle theta. And then based on the fact that the cosine of 2 theta was this ratio, we picked our replacement identity. We solved for the value of cosine, and that let us label the triangle. And even though it said find the values of the 6 trig functions, we found cosine of angle theta, and we said now that we've got the triangle drawn, we wouldn't have trouble getting any of the others, right? Yes. So let's look at this. We want to simplify these, noticing that we have something, bless you, that has a coefficient in front of the x. It's not just 2 cosine squared of angle x. It's the 2 cosine squared of angle 5x. So here's what we might need to look at. Since our double angle properties, and this was a cosine, so remember we've got multiples here. I've got 2 cosine squared of something minus 1. Doesn't that look like this? It does. The difference is that theta is equal to 5x, right? Okay. And if I were to take this and replace it, 2 cosine squared of theta minus 1, that matches this double angle property now, which means it's equal to what? Cosine of 2 theta. And now if I go back and I replace theta with 5x, that means that this is equal to what? Cosine of 10x, that's it. Does that make sense? We just noticed because there is that coefficient in front of x, it's not just an x, it's a multiple of x. So we're going to try to find a suitable replacement using that double angle property. And by just simply replacing the 5x with theta, it made it easier for us to see, oh, that's equal to cosine 2 theta. And then we can do the replacement. Now, look at this one and see if you can tell me what you think we might want to replace. What do you think?
No, I said that's it.
Oh, yeah, that's it. That's all you had to do is simplify it into cosine of 10x. Now, on this one,
Do you have to do the product to some form?
I don't know. What do you think? Because it does say use double angle identities. Now, if we look back at these double angle identities, sine of an angle times cosine of the angle kind of looks like, oops. Yeah, except what's missing? The 2 is missing. So let's see if we could figure out if we let, and let's just, instead of theta, let's use A. Let's say that's 165 degrees. Okay. Then the issue is that we are missing the 2 that needs to be there. Okay, that part is missing, times the sine of 165, cosine of 165. Now, I can put a 2 in there as long as I balance it out correctly, okay? So here's the idea. Since I needed the 2 and it wasn't there, that's why I stuck it in with the parentheses, because I could take the sine 165, cosine 165, multiply it times 2. But so I don't change the meaning of what we have, what would undo or offset multiplying something by 2? Dividing by 2, which would be the same thing as multiplying by 1/2, wouldn't it? Okay, does that make sense? I could put the 2 back in there as long as I also multiply it times 1/2. Now, if that's the case, I can clean this up because now this part has a replacement. 2 times sine of A cosine of A is what? Yeah, it's sine of 2 times whatever that angle is, but I've also got this 1/2 that's in front that I have to keep. So 1/2 times the sine of 2 times 165, right? Or 2 times A, if we wanted to put it there and then go back and replace A with 165. So I can multiply these 2 together and I get what? 1/2 times the sine of, how much is 2 times 165? I think it's 330, isn't it? Yeah, 330 degrees. Okay, now if that was all we could do, we would stop there. But we always want to ask ourselves, by any chance, is that a special right triangle? What do you think? It is. If I were to sketch this, 330 is here in the 4th quadrant. And if that's 330 to get here, wouldn't this be a 30-degree angle? I think we can find the sine of 330, don't you? So what would this side length be? And is it +1 or -1? -1. And what would this side length be? Square root of 3. Hypotenuse is 2. So this would equal 1/2 times, how much is the sine of 330? -1/2. So that's equal to what? Oh, come on, just multiply. 1/2 times -1/2 is? Yeah, you multiply positive times negative, it stays negative, and then multiply straight across. Yeah, -1/4, that's it. Make sense? Okay, the next one, because we're a little short on time, and it's actually deriving the identity. Those are a little challenging. We're going to skip it. Okay? So I'm just going to hit kind of the things that I would say are the important things you need to know how to do. This is another example that talks about voltage. We could do it, but I think for the sake of time, let's skip it too. Because we do need to make sure we cover all the different identities we're going to need. So let's talk about product to sum and sum to product identities. If you're looking on your sheet, here's where you see product to sum and sum to product. So product means we started off with things being multiplied, and then we're going to rewrite them as things that get added or subtracted. We can also go the other direction. So on this one, if I look at cosine A times cosine B, that looks like this one right here, okay? And so all of these are going to come out of this section. So you guys tell me, what would you write down for cosine A times cosine B? Start with 1/2. I need a bracket, and then what goes inside? Good.
Cosine plus B.
You got it. Cosine of angle A minus angle B plus cosine of the sum, A plus B. Very good. Now, when it's sine A times sine of angle B, this may be a little bit surprising because going to the sum still uses cosines, doesn't it? Cosine of A minus B, but this time we subtract the cosine of A plus B. Now, I realize you're going to have a formula sheet, but it also sort of helps when you notice patterns and you kind of get stuck in your head, things to watch for. So notice on these, you're either multiplying cosine times cosine, which is the same thing, or you're multiplying sine times sine. So as long as you're multiplying together the same ratios, what shows up in the parentheses? Which ratio? You see what I'm saying? Cosine and cosine are the same. Sine and sine are the same. So as long as I'm multiplying the same ratio times the same ratio, when I look at this pattern, the only ratio showing up in this parentheses is which one? Cosine. So they both involve cosine. In fact, the only difference is if it's cosine times cosine, you add them. If it's sine times sine, you subtract them. Okay? What do you think is probably going to happen when we have a sine times a cosine? Yeah, we're going to get sines that show up. So 1/2 onto the bracket of, this will be the sine of A plus B plus the sine of A minus B. Okay, so we have one other change. When we were multiplying together the same ratios, cosine times cosine or sine times sine, not only were they both cosines showing up in the brackets, but the first one was the difference. It was an A minus B in both cases. Now that we're multiplying different ratios together, sine times cosine, not only do sine show up, but we're going to change and have an A plus B that shows up first. And that means cosine A times sine B ends up being sine of A plus B minus sine of A minus B. So we do not get mix and match on cosines and sines ever when we go from products to sums. Instead, we'll have to just pay attention to whether we start with cosines or we start with sines, and then watch out for the SIGNS in each one. But again, you will have this. You just got to make sure you choose the right one. Now, anybody concerned about the fact that when you have this many and they are so similar that you're going to accidentally pull the wrong one? That means watch carefully and double check yourself before you get too far into it.
Well, yeah, when we do this, we'll be able to.
Yeah, you get to use that formula sheet when you test. So as long as you just want to make sure you practice with it, so when you're doing homework, you're looking back at it, and you know where to find the section, and you know how to read it carefully, especially on those formulas that have both the plus and the minus mixed in together. Okay, using a product to sum identity. So let's see if we can figure out what we could do with this one. It says write 6 times the sine of 40 degrees times the sine of 15 degrees as the sum or difference of two functions. Now, if these had been special right angles, like sine 60 times sine 30, would we be able to just plug in and solve it? Yes, we would. But since it's not, we're going to see if using the product to sum identity would then give us something we would know how to evaluate. All right? So does it make sense in trying to figure out when you need to use it? Okay, good. Because as long as these are special right angles that I can look up and find those, I don't need the identity. But I don't know what the sine of 40 is or the sine of 15. So let's see if it gives me something I can work with when I come up here and choose the right one. So you guys tell me which one I need. This one right here, right? So this is going to turn into, and I'm just going to recopy what we have, 6 sine of 40 times the sine of 15. And we'll call this one A, this one B. It might help us a little bit when we plug in. So that's equal to, do I need to write down the 6? Please say yes. Yes, don't lose it. Okay. And after I write the 6, that's when I start with this. So I'm going to put a bracket before I put the 1/2. And then inside, I'll use this. And I'll have the cosine of, now what do I put in the parentheses? A minus B. And since A is 40, minus B is 15, that's how that's going to look. And then I have minus, that'll be in degrees, the cosine of, what do I do in the second one? Yeah, I take the sum, so it becomes 40 plus 15. All right, so let's see if we can clean this up a little bit. Can I go ahead and multiply the 6 times 1/2? I believe so. That's going to be what? That's going to be 3. This is going to turn into the cosine of, well, how much is 40 minus 15? 25. And then minus the cosine of what? 55. There you go. Now, as it turns out, these still are not special right angles, so I'm not going to be able to figure these out just using those special right triangles, but the instructions simply said to write it as the sum or difference, and now I have, okay? And depending on what I'm working with, there could be an advantage to having it in this form, which you can find sometimes by using these identities. It gives you something you can actually kind of clean up, okay? All right, so any questions on this so far? All right, turn page. And these are going to be the identities that we use when we're going the other direction, if we want to take something from a sum to a product. So that section is right here, and all we have to do is use these formulas. So let's see if we can get those on our paper. If I'm adding the sine of A plus sine of B, instead of multiplying by 1/2, I actually multiply by what? 2. And that gets multiplied times the sine of, and I'll take A plus B and divide it by 2 times the cosine of A minus B, and that gets divided by 2. Okay? Now when I'm taking the difference, I still have 2, and I multiply that times the cosine of A plus B divided by 2 times the sine of A minus B divided by 2. All right, so the patterns that we identified when we were going from product to sum don't look the same here. All right, so you may look at some other things that will help you keep it straight. But make sure you realize these have to multiply by 2, not by 1/2. Okay, what do we put down for the cosine of A plus the cosine of B?
2 cosine.
2 cosine, and the first angle measure is A plus B divided by 2. And then we have the cosine again of A minus B divided by 2. And then on the difference, we have something that is slightly different. What do we need? Not just 2, but -2. And it'll be the sine of A plus B divided by 2 times the sine of A minus B divided by 2. Okay. So you may notice here, if you're adding or subtracting signs, you do mix and match sine and cosine when you turn them into products. But if you're adding or subtracting cosines, then you're going to use only one of the ratios. Cosine plus cosine will be cosine times cosine. Cosine minus cosine will be sine times sine. All right? And again, you're not having to memorize these. You just need to make sure you can find them on the formula sheet. So, can you take the cosine of 3 times angle theta plus the cosine of 7 times angle theta and write it as the product of two functions? Okay, so tell me what would we need to think of 3 theta as being? A. And 7 theta would be B. Exactly. So knowing that, let's look back up here, see if you guys can tell me how you would rewrite this as a product.
Cosine parentheses 3 theta plus 7 theta over 2 times cosine 3 theta minus 7 theta over 2.
Do y'all agree? Is exactly right. That's all we're doing is finding the right one and plugging in. Now, let's see if this cleans up a little bit. This will be 2 times the cosine of 3 theta plus 7 theta is, and 10 theta divided by 2 is, there you go. And then that gets multiplied times the cosine of what? 3 theta minus 7 theta is
-4 theta.
And -4 theta divided by 2 is -2 theta. Now, in general, they're not going to want you to leave a negative angle measure here. They're going to want you to use these even odd formulas. So if it's a cosine of a negative angle, that's equivalent to what? The cosine of the positive of that angle. So final cleaned up form is 2 cosine 5 theta times cosine of 2 theta.
So this cosine condition would be changed to positive.
Yes, by using the even odd formulas. If it had been sine of -2 theta, how would we have changed that one? It would have been a negative in front of the sine times 2 theta. I'm sorry, not times 2 theta, the negative of sine of 2 theta. All right. Now let's talk a bit about half-angle identities. So with these half-angle identities, make sure you realize when you see this plus or minus, that indicates that the sign is chosen based on the function under consideration and the quadrant that your angle divided by 2 is in. So let me show you what we mean by that. All right, your half angle are here, okay? So notice there's this plus or minus. So what it's saying is I've got to figure out if theta is, let's say theta is 210 degrees, okay? Then where would theta over 2 be? 210 divided by 2 is 105. Which quadrant is 105 in? It's in quadrant 2. And then I would figure out, is sign positive or negative in quadrant 2? Exactly. All right, so that's how you decide whether it's a positive or a negative.
What's the alternate form on the side? It says like up on the half angle.
Oh, yes. That's where they have given you a different replacement if you need to, and what it's going to do is let you go from something that was squared to where you're using a double angle.
Gotcha.
Okay? What they've done really is just kind of rearrange the formula and put it in this form. And I will tell you, when we do calculus, oftentimes we do have to make replacements using these in order to get something that we're able to integrate, which I know you're not there yet, but you will understand once you're in calculus. So let's look at these formulas. The cosine of some angle divided by 2 is plus or minus square root of 1 plus cosine of angle A divided by 2. Okay? The sine of angle A divided by 2 is either positive or negative square root of 1 minus cosine of angle A, and that gets divided by 2. So our cosine and our sine, we have one form each. Now, this is showing us that, bless you, we have one form here. I'm going to give you, there are actually 3 variations of this. Depending on what you're working with, you may find one of these works better. You know how we had 3 variations for the cosine of a double angle? We've got 3 variations for the tangent of a half angle. So this is the one that's on your sheet. It's either plus or minus square root of, and your numerator is 1 minus cosine A over 1 plus cosine of A. Okay? This one is not on your sheet, but you might decide you want to copy it over. Okay? Huh?
That's the one.
That's the one that's on yours. These 2, I don't believe you're going to find on there. You'd have to do some serious rearranging to figure them out. So if you want to copy these on there, you're welcome to do that. You could also use the sine of angle A over 1 plus the cosine of angle A. And notice that one doesn't have a radical. And then the tangent of angle A divided by 2 could also be written as 1 minus the cosine of angle A over the sine of angle A. Okay? So these are all variations we can use if we need to use a half angle identity. Now, let's look at this. It says find the exact value of the sine of 22.5 degrees using the half angle identity for cosine. So sine has only one variation, and here's how this thing works. The problem is, if I asked you to find the sine of 22.5 degrees, that is not in a special right triangle, right? But can I replace 22.5 degrees as something that's an angle divided by 2? What angle do you divide by 2 to get 22.5? If you don't know, exactly. You would take 22.5 and multiply it times 2 and say, wait a minute, that's 45. I can work with a 45-degree angle. So this is letting us replace the sine of 22.5 degrees with the sine of 45 degrees divided by 2. Now, by doing that, I can use this, and I will figure out whether I need the positive or the negative. Now, all of these end up being in which quadrant if I'm starting with 45 for my angle? 45 is in quadrant 1, 22.5 is in quadrant 1. So do I need the positive or the negative? Positive. And that will be the square root of 1 minus, I'll do the cosine of which angle?
45.
Good. My A is whatever this is. So cosine of 45, and that thing's going to be divided by 2. Now, how much is the cosine of 45? So 45 has 1 square root of 2. All right, so it's going to be the square root of 2 over 2. And this whole thing is being divided by 2. So let's do a little bit of cleanup. I might want to think about rewriting 1 as what? Yes, I need to get a common denominator. So can I write it as 2 over 2? And that would, and by the way, this whole thing is under the radical. So that would give me square root of, and I would have 2 minus square root of 2 over 2, which is my numerator. And instead of leaving this in fraction form, can I multiply by the reciprocal? Times 1 over 2. Right? So I don't have a fraction over a fraction. I can leave, change, flip. And now that gives me square root of, I have 2 minus the square root of 2 over what? 4. Now, in terms of cleaning this thing up, I can't do anything really with my numerator. But remember, if I'm taking the square root of a fraction, it's the same thing as the square root of the top over the square root of the bottom. So is there some way that I could clean up the denominator? Instead of leaving 4 under the square root, it actually turns into what? Yeah, the square root of 4 is 2, but it's in the denominator. So I could write this as 1/2 times the square root of 2 minus the square root of 2. And I'm going to let you leave the radical under the radical. That's okay to do that. How we doing? Okay, let's see. Let's look at another one. Find the exact value of the tangent of 75 degrees using this identity. Now, tangent of 75, I do not know. But I could rewrite it as what using this? Here's what you have to do. If I'm seeing that this is not something I know, to use either the double angle or the half angle, I check to see if I divide this by 2, does it give me something I recognize? The answer is no. If I multiply by 2, does it give me something I recognize? Because 75 times 2 is what? 150. And if I have 150 degrees, I'm in the second quadrant, but what's my reference angle? 30, yeah, because this would be 150. So here's what that means. I want to rewrite that as the tangent of 150 divided by 2. And it's telling me this variation is the one I want to use. Okay? So here's my reference triangle. I know I'm in quadrant 2. So let's see if we can label these sides. How much is this one? 1. This one would be a negative square root of 3, and the hypotenuse is 2. There you go. All right, so we want the sine of 150 divided by 1 plus the cosine of 150. So now I'm going to use my triangle. And what am I going to get? The sine of 150 is 1 over 2. Opposite over hypotenuse is 1/2. And if it's okay with you, I'm going to go ahead and write it this way. Divided by, and I'll have 1 plus, now how much was the cosine of 150? A negative square root of 3 over 2. Are we good with that? Okay. Now, I wrote it this way, but this needs to get cleaned up to be one single fraction. So how do I make that happen? Think of 1 as being 2 over 2. And that means I have 1/2, and that's divided by 2 minus the square root of 3 over 2. That makes sense? Y'all stop me if we're going too fast on any of this. What would you want to do now? Multiply by the reciprocal. Leave, change, flip. So I have 1/2 times, this 2 goes on top, the 2 minus square root of 3 goes on bottom, and what do you notice you can do? Anything? I have a 2 on top and a 2 on bottom. They're being multiplied. They're common factors. These I can reduce down. Can I do anything with this 2? Don't do it. Remember, there's a minus sign there. That's not a factor. That's part of a difference. That's one of the terms in the denominator. It's not a factor, so I can't touch it. And that's going to give me 1 over 2 minus the square root of 3. Now, that would be fine as long as we are told we could leave radicals in the denominator. They usually tell us not to do that. We try to avoid that. How in the heck do we get rid of the radical in the denominator? Yeah. Okay, let's take care of your question. Up here? Flip the 1/2? Okay, would that be legal to flip the first one instead of the second? No, can't do that. It would have made it nice because then we wouldn't have had to worry about the denominator. But nope, it's got to be leave the first one alone, change, and then flip the second one. So,
Would that turn into square root of 1 or -1?
no, here's how you get it out of the denominator. You multiply by the conjugate. There's 2 terms here. So we can't just multiply by square root of 3, because if we distribute through, we get rid of the square root here, but we create 1 here. The conjugate means it's just like this, except we do what to the sign? Change it. So we need to multiply top and bottom by 2 plus the square root of 3. Now, is that still equivalent to 1? 2 plus square root of 3 divided by 2 plus square root of 3. Yeah, as long as I'm multiplying top and bottom by the same thing, it's equivalent to multiplying by 1, and I can multiply anything by 1 and I don't change the meaning. So now 1 times this means my numerator is 2 plus the square root of 3. In my denominator, I've created a difference of squares. And that means my first times first, 2 times 2 will be here. But what happens when I multiply outer times outer and inner times inner? They cancel because one's positive and one's negative. So I just have to multiply the last times last. What do I get? What's a negative square root of 3 times a positive square root of 3? Negative times positive gives me a negative. And what's the square root of 3 times square root of 3? It's 3. Okay, you think of it as square root of 9 if you want, but square root of 9 simplifies and becomes 3. And 4 minus 3 is what? 1. So this whole thing ends up being 2 plus the square root of 3. I don't think that the Precal is hard on that, but you do have quite a bit of algebra you've got to apply. Now, before you get too panic-stricken, you're not going to get overloaded with too much of this on the test, okay? But we're going through as much as we can to reinforce the algebra skills. You may see a few of these in the homework, but I'm not going to just, give you problem after problem after problem like this on the test. Does that make sense? Okay. Now, what do you think we would do with this? We're given that the cosine of angle S is this ratio. And we know that angle S is between pi and 3 pi over 2. Now, what does that tell me about angle S? Why would I need to know that? Okay, angle S is in the 3rd quadrant. We're supposed to find the sine of S over 2, cosine and tangent of these angles. Now, in order to do that, I've got a little bit of an issue, would you think? Yes, no, maybe? Okay, they've given me one value for the cosine of angle S, but I am supposed to find these values. Now, remember, the value of S is in the 3rd quadrant, but do I know where S over 2 is? I don't, unless I do this. I'm going to take this inequality, and could I divide everything by 2? so that this will tell me where S over 2 is located? I can. I'm going to divide that by 2. I'm going to divide that by 2. And you can think of this as divided by 2, but that's the same thing as times 1/2, right? So if I clean this up, I've got S over 2 is between pi over 2 and 3 pi over 4. So what quadrant is that located in? Pi over 2 and 3 pi over 4. That's in quadrant 2. Okay, now what that tells me is when I use these formulas, I will pick the SIGN that would go with this ratio being in quadrant 2. All right? Now, if we want to find the sine of angle S over 2, let's look at our formula sheet for a minute. Okay, sine is going to be positive in quadrant 2. I agree with that. And sine, notice all of these are given to us in terms of cosine. So do I even need to worry about what any other ratios would be? There's not even a reason necessarily to draw the triangle, because all I need is the cosine of angle S for my formulas, right? You guys follow what I'm saying? Okay. So sine of angle S over 2 is going to be, and you said it's positive because it's quadrant 2, and that would be the square root of 1 minus the cosine of angle S divided by 2. All right, see if you can tell me how to plug into that. What did they tell us the cosine of angle S was? Yeah, that's a negative 3 over 7. And that gets divided by 2. So minus a negative turns into plus a positive. If I want to add 1 plus 3 over 7, what is that going to turn into? I could think of that as 7 over 7, right? So it would turn into the fraction 10 over 7 in the numerator, and this would be divided by 2 over 1. But can I go ahead and change that to multiplying by the reciprocal? Sure. So 10 over 7 times 1 over 2. What happens with the 10 and the 2? Well, that reduced down. And I get square root of 5/7. Now, because the whole fraction is under the radical, I have a radical in the denominator. How could I get rid of that? If I'm thinking of this as the square root of 5 over the square root of 7. Well, I don't want to multiply by itself. I want to multiply by something equivalent to 1. Good. Multiply by the square root of 7 over the square root of 7. Because I'm okay with a radical in the numerator. I just don't want it in the denominator. And that's going to equal what? Square root of, what's 5 times 7? 35 over, what's my denominator now? 7. Good job. Okay. How about the cosine of S over 2? You guys want to try that yourselves? Let's see if you can do it. Okay, so when you plugged in, you looked on your sheet and you said the cosine of some angle divided by 2 is, we knew it was the radical 1 plus the cosine of angle S divided by 2, but because we were in quadrant 2, we know cosine is negative. So we don't want to lose that. Now, if I plug in, I get a negative square root of 1 plus, and my cosine of angle S is negative 3/7. So that turns into this. And how much is 1 plus a negative 3/7?
4/7.
Yeah, because it's 7 over 7 plus a negative 3 over 7. So we would have a negative sign. We would have the square root of 4/7 And then that would be over the square root of 2, if you want to think of it like that. Or you could put it all under one. Actually, let's not do it that way. Let's do it this way. We've got this, and instead of dividing by 2, can we think of it as multiplying by 1/2? Let's do it that way, okay? And that gave us a negative square root of, this ends up turning into, 2 goes into 4 2 times, right? Over square root of 7. So if you multiplied top and bottom by square root of 7, you got a negative square root of 14 over 7. Good job. And then on tangent, the formula that we need to use, now first of all, deciding quadrant 2 is tangent positive or negative? Negative. And we have 1 minus cosine theta on top, or cosine of s, over 1 plus cosine of s. So let's see if you can tell me what we're going to end up with on this. What am I putting in for cosine of s, both spots? A negative 3/7. So we've already done both of these. Minus a negative turns into plus a positive. That means we're going to get what for the fraction in the numerator? Because it's 7 over 7 plus 3 over 7 is 10 over 7. And that would be divided by, and our denominator turns into what? Yeah, 7 over 7 minus 3 over 7 is 4 over 7. So if we leave change flip, we get negative square root of 10 over 7 times 7 over 4. And the 7's cancel. What can I do with the 10 and the 4? Yeah, I can end up with, actually, you know what? It might be better not to reduce down. Because what happens if 4 is in the denominator and it's the square root of 4? Exactly. That's going to be a negative square root of 10 over 2 when it's all cleaned up. Now, if you ended up reducing the 4 over 2, you would end up getting back to this. It's just kind of, you would clean it up, then you would have to rationalize, and then it's going to turn back into this. Okay? So how are we doing? You guys are very quiet, but you're hanging in there, so that's good.
Most of this section, but I'm kind of doing this part.
Okay. Good. Okay. And I do think, and in a minute, I'm going to show you what things will be on this first part of the test. And I'm hoping it will be things you will feel relatively comfortable with. And the more you practice, the better you get. All right. This simply says simplify each expression. So when you look at this, does it make you think that this looks like the formula on a half angle? I would think so. Anytime you see that radical and you've either got a 1 plus cosine of something or a 1 minus cosine of something, I would think about that. So let's decide which one this most closely matches with. This one right here. Now, if that's the case, theta is going to equal what? 8x. Correct? Yeah. Okay. So what we want to do is replace theta with 8x over here. So this is going to be equivalent to the sine of 8x over 2, which is the sine of what? And you know what? That's it. That's all you had to do is figure out, yeah, how to write it using that half angle identity and clean it up. Now, what does this look like? That looks like that's going to be a tangent. And if that's the case, what would you tell me that theta is equal to in this one? 9b, beta. So if theta is equal to 9b, then looking back here, this would have to equal the tangent of what?
9b over 3.
You know what? There's nothing else I can do with that. That's it. Those are pretty cool, right? Okay. This, I know it didn't print out right. I could tell you what it is. We could go through it, but I don't think I would, I'm not going to require you to do that. As far as verifying identities, that's going to be the stuff we did 7172. So let's skip this. And we just finished everything that is in 7.4. So before we start 7.5, let me tell you what I want you to focus on to be prepared to do the test, because you have until next Tuesday to get to the testing center to do that test, okay?
It's a quiz, right? Or
Well, there's a quiz and there's a test. Okay, so here's the deal. Your quiz is over 7172, and Monica's done it's 5 questions, right? Okay, and you do have, I've attached the trig cheat sheet to it, so you have all of those identities to use. And in fact, it was set up with some multiple choice so that you could kind of tell when you'd gotten to a good stopping point. All right, then, okay, I see it here, I must be on the right track. Now, the test is going to be 7, 1, 2, 3, 4, and I'm giving you a week to be able to get into the testing center to do it, okay? And I will also give you a little guidance in like verifying some of those identities. There will be some multiple choice. Now, again, you get no credit if you just circle something and say, oh, this is what it's equivalent to. No, you're going to have to show me what you do to get there, all right? And that's what I'm grading is your work, not specifically the answer you write in the blank. So you might want to take your notes packet and mark these things I went through to try to show you. I don't have a specific review sheet, but I'm going to indicate these are the kinds of problems you need to be sure you can do on the test. And then if there's anything we need to go over together, we will. So if I give you a ratio for some angle and tell you which quadrant that angle is in, would you be able to come up with any missing values? We've done quite a bit of that. Do you feel pretty confident with it? Because as long as you've got one ratio, you can use Pythagorean theorem to find the third side, right? And if you pay attention and sketch it out, you get the right SIG and S on there, then you can give me any of those. So make sure you can, bless you, you can do something like that. Now, you're going to get 1 or 2 of these where I give you some expression, and it's going to tell you to write it in terms of sine and cosine and then simplify it. And it may tell you to be sure your answer has no quotient in it. It may tell you to be sure your answer just uses sines and cosines. It kind of depends on the question, but make sure you would know how to do these kinds of things. I will remind you the replacing things with sines and cosines many times will give us something that's easier to work with, and then you can finish all your cleanup on that. Now, when you get to the verifying identities, here's a couple of examples. These will not be multiple choice because you already see what the goal is on the other side. You're trying to get one side to turn into the other. But this is where you want to remember changing things to sine and cosine might help. And then you want to go through and clean up. In general, anytime you have fractions, you're going to want to try to get a common denominator if you can. Or in this case, you had to distribute through and then you were able to clean up. So make sure you can do those. So that's 7172. When we got to 73, sum and difference, be sure you can do something like this. If you've got it written out this way, that you would know how to put it back together and write what it's equal to. If it turns out when you put it back together, it's something you can identify because it's either a quadrantal angle or a special right triangle angle, then you go ahead and you simplify it. If it had been the cosine of 54 degrees, you just leave it cosine of 54.
What's the testing center like? Are we doing this on computer?
No, it's going to be paper test. I will have your formula sheet attached to it. There's no time limit on it, and it will indicate that you can use, actually on these, I don't know how much you would even need a calculator, but because it's not going to ask, anything we're doing, we're using special right triangles. So the main thing is you got to know how to work with radicals, and depending on your calculator, you can kind of verify you did it right by, so I'll say you can use a calculator. I just don't know how much it's going to help, other than it might let you confirm that you simplified things correctly.
Someone in there to give us the test?
Yeah, there is a proctor. If you haven't ever been to the testing center, it's in the building A, the first building over here, and it's A101. You have to come. Yeah, there's a sign there that says testing center. You got to be sure you come with student ID when you come, because they're going to have you sign in, confirm who you are. You got to know my name. Amazingly, at this point in the semester, I sometimes have people go and take tests, and when they say, "Who's your instructor?" and they say, "I don't know." So hopefully you all know my name by now, Ms. Becker. And they will give you the test and tell you where they want you to sit while you work. When you have to make sure you don't have a cell phone with you. If you do, you leave it on the desk while you're testing. Backpacks, things like that, but have to stay up at the front. And when you finish, you turn everything into her, and then she will get it to you. Okay? Testing center hours open at 10 a.m., close at 7 p.m. Monday through Thursday. But you have to be there an hour before closing in order to test, and it's open from 9 to noon on Friday. Is that going to be an issue, or is that okay? Okay, all right. Thursday, yeah. So make sure you do the quiz by Thursday, and then you'll have till next Tuesday class time to get the test done. All right.
Do you know if we're going to be able to use our calculators on the test, or
yes.
the ones that you provide?
No, you can use your calculator. Okay. Here's another one that you might want to mark and be sure you feel comfortable with one like this. This would be going the other direction with a summer difference. Now, it won't necessarily be a negative angle measure, but we figured out a way to replace whatever the angle measure is with a sum or a difference. And then we use that identity to be able, because if that one you're going to have to be sure you can replace it with values that are special right angles. Okay, so that kind of gives you both directions on those. And out of 7-4, what we did between last class and today, if I give you an angle measure that I give you the ratio for it, either sine, cosine is probably what you would get. And this information, then you need to be able to use these double angle identities and come up with the values. So we plugged in on that, and then there would also be, from what we did today, a half angle. So make sure if you're given something that using the half angle identity, you would be able to work your way through this to see what to get. Okay? And that's pretty much everything that will be on this test. Okay.